In lesson 4.7, we're going to be doing inverse trigonometric functions, which means we're going to be finding the angles. In order to do this, we're going to have to remember our special right triangles. The 30, 60, 90 right triangle and the isosceles right triangle. So if we are asked to find the exact value of the inverse sine of radical 3 over 2, we can think of it in degrees, but then our final answer is going to want to be in radians. So that's what they're going to want when they say find the exact value. So the first thing you have to do is remember so, ka, toa. The sine is the opposite over the hypotenuse. So you refer to your 30, 60, 90 triangle and you see which angle, either the 30-degree angle or the 60-degree angle, has the opposite over the hypotenuse equal to radical 3 over 2. So the opposite of 60 is radical 3, and then the hypotenuse is 2. So that's where I'm getting 60 degrees. And then using what we learned in the previous lessons, to convert that to radians, you multiply by pi over 180 degrees, since there are 180 degrees in pi radians. So then in lowest terms, this becomes pi over 3. In the next one, we want to find the exact value of the inverse sine of negative radical 2 over 2. So the first thing we have to do is realize that we're working with the 45, 45, 90 triangle because that's the one that has the radical 2 in it. And we're going to use, again, opposite over hypotenuse, and it doesn't matter which angle, they're both going to be the same. The opposite is 1, the hypotenuse is radical 2, but then when I rationalize the denominator, then I get radical 2 over 2. And then it's 45 degrees, but a negative means that we are going to be in quadrant 4. And that's because in your book, on page 614, it talks about the inverse sine function limiting our terms to negative pi over 2 and pi over 2. So that means when you're dealing with your coordinate plane, we always start our turns here. A turn of pi over 2 is here, so that's using quadrant 1. A turn of negative pi over 2 is here, that's using quadrant 4. So because this is negative, that means we're going to be in quadrant 4, so that means it would be a clockwise turn. And once again, exact value means turn it into radians, so you'd multiply by pi over 180 degrees. Now, to find the exact value of the cosine of negative 1/2, the cosine has a different limitation to the turn than the sine was. We had said the sine was in quadrants 1 and 4, but on page 617 in your book, the inverse cosine function is limited to a turn that is between 0 and pi. So that means your cosine is going to be, the inverse cosine is restricted to these two quadrants, 0 to pi. So if we have a negative, that means that we're going to be in quadrant 2. So keep that in mind. We're going to try to find so ka toa, cosine is ka, the adjacent over the hypotenuse. So it's either the 30-degree angle or the 60-degree angle. In this case, it'll be the 60-degree angle, adjacent over hypotenuse. And then that becomes our reference angle. So if you remember, reference angles are always made along the x-axis. So what we're saying is this angle, obviously not drawn to scale, is 60 degrees. And so in order to get to that location, we have to turn this much. And since this is 180, if we subtract 60, it's a turn of 120 degrees. So then we come back and we turn 120 degrees into radians. So it will be 2 pi over 3 radians by multiplying by pi over 180 degrees. All right, now tangent, finding the exact tangent, inverse tangent of -1. So for the tangent, it is going to have the same limitations as sine, and this is on page 618 in your book. The tangent is limited to a turn of negative pi over 2 to pi over 2. So just like sine, we're only going to be in quadrants 1 or 4. So if this is a -1, it must be in quadrant 4. 45 degrees is going to be our reference angle. How did I know that? The tangent of 45 degrees is opposite over adjacent, TOA. So whether it's 1 or -1, it's a 45 degree reference angle. If it's in quadrant 4, we're going to be turning this way, so it's a negative turn. So it's -45 degrees, which is negative pi over 4 radians. All right, now if they ask you to use a calculator to find the value of the inverse cosine, super easy. Just make sure you are in mode radians. So we're going to do inverse cosine of 1/3. So you go into your calculator, make sure your mode is in radians. It is. And then I'm going to do second cosine. That's how I get the inverse cosine. 1/3 is 1 divided by 3, close parentheses, and then that gives me the value. So that's what I want to do